This is a video for the lesson 5-2 notes. So we've already talked about congruent figures in the previous lesson. Now we're going to talk about congruent triangles, and we're going to use all the tools we've already learned through the pink sheets. So we're going to be given several different problems, each of which has two different triangles. We're trying to determine if these triangles can be proven to be congruent using any of the four methods we now know. Side, 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 angle, side, angle, and angle, angle, side. And just so you know, there will be some of these that are not going to be congruent. And in that case, you can just say NA for, none of these apply. Not applicable. Okay, so what you need to do is be really careful with these and mark your figure whenever needed. This one, number one, is already marked for you. We have a triangle on the upper left and another triangle on the lower right. We got a side with one hatch mark, and same thing for the other triangle, and then a double hatch mark. Well, we got side, side already, but notice, what do we also have? We have a third side, that's the reflexive side. Reflexive side means it's shared between this side, it's shared between triangle 1 and triangle 2. So what do we have? We have a hatch mark for one hatch mark, 2, 3, so that's side, side, side. And then in the same exact order, we need to go around in the same order. Side, side, side. So for both of those, we have side, 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 and it matches the other one. So that one, you can't really go wrong with side, side, side. It's usually pretty straightforward, as long as you recognize that there's a reflexive side. So what do we have here? We have a single arc for an angle, a single slash for an included side, and we have a double arc for another angle. Do we have that same thing here? Well, if we go from left to right, it's in a different order, but we don't have to go to left to right. We can go from right to left, and we have a single arc, a single slash for the included side, and a double arc. So what do we have? That's angle, side, angle, and angle, side, angle, and these two that I just marked match each other. So that is angle, side, angle. For the third one, what do we have? Well, we only have a single slash and a double slash, but what else do we know? There's these angles formed by the intersection of two lines. So what you have to do is use a little bit of your geometry knowledge from previous chapters and know that these are vertical angles. So that then gives us side, angle, side. Single slash, single arc, double slash, side, angle, side. So we have single slash, single arc, double slash. So side, angle, side, side, angle, side. Always make sure you're going in the same order. So that brings us to number 4. Side, a single side. Oh, well, that doesn't actually work. Notice this from here, this single slash side to over here. I'm skipping this whole side, so I can't go side, angle, side. Instead, I would need to go the other way. I could say side, side, angle, or angle, side, side. Remember, that's not one of the ways we know. We're not saying ASS or SSA. That is not one of our 4 shortcut methods. Let's see what happens with the other one. Again, we have side, side, angle, or angle, side, side. So this none of those apply, and the reason, and what that means is if none of them apply, we can't actually prove that these triangles are congruent. So the only conclusion you can really make is no conclusion at all about their congruence. So we're going to just say we're not going to be able to determine that they're congruent from this information. Going on to number 5, We have a right angle in each. We have a side that's been indicated to be equal. What else do you know? Again, we have vertical angles. So let's see what that gives us. Side. Okay, we have angle, angle, side. So what do we have after we've got our vertical angles? We have angle, angle, side. Okay, so whenever you're talking about angles, you can't ever skip an angle. Just like when you're talking about sides, you can't skip a side. So I'm saying angle, then the very next angle, and then the side. And notice I started off with the right angle, then the vertical angle, then the side adjacent. Let's do the same. Start off with the right angle, go to the next angle, because that's the very next angle you come across. Then the very next side you come across is right next to it. So that's the same order we went in. Right angle, vertical angle, and then the side. Well, what do you call that? That's just angle, angle, side. And that is one of the 4 ways we can prove congruence. Well, let's see what we have in number 6. Anytime where you have this, what we call a bow tie pattern, where it looks like the left side and the right side of a bow tie, you're almost always going to want to know that you have vertical angles, because that's what happens when you have 2 lines intersecting. You get vertical angles. Let's see if that gives us anything. Angle, angle. Oh, first of all, that should be a double arc, because we already have a single arc. Angle, side, angle. Angle, side, angle. So that's exactly what we have. We can prove congruence using angle, side, angle congruence. Well, how about number 7? We have a side and we have an angle. Notice both sides are on the left, but not both angles are on the left. But what else do we notice? We also have a reflexive side that is shared between the 2 triangles. So we have, you could say angle, side, side, if you wanted to say that. Angle, side, side, though, is not one of our methods. Neither is side, side, angle. And what do we have if we go the other way? We have this reflexive side yet again, side, angle, side. So are they the same? Side, angle, side, and angles, side, side? They're not. So we could say side, angle, side, and then you might be tempted to say side, angle, side over here. But this side we skipped over, and we can't do that. We can't skip any sides if we're talking about sides. Side, angle, the other side would have to be right here, and it's not. So we're skipping over that side. So we're really saying angle, side, side. So what we have here is we have a different order. And because of that, they're not going to be congruent. And to answer with the instructions, we would just say none of these 4 apply. Okay, then number 8. We have 2 triangles. They're not sharing a side this time, but what do we have? A single slash, a double slash, a triple slash. Let's see if we can go find that in the other one. A single, a double, a triple. If they're all the same, we have side, 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 and then the other one also has side, side, side. So what do we get? That's exactly what we have, just side, side, side congruence. If you take your time on these, you shouldn't ever make a mistake, but if you rush through them, you might. Let's see what happens on number 9. Side, angle, side is what it looks like here. That seems pretty clear, right? Side, angle, side. And then look, we got We got a side, and an angle. Are they in the same order though? Single slash, angle, double slash. We actually have angle, side, side, and this is side, angle, side. So again, you have the different order. And because of that, they're not congruent. And none of these four methods of proving congruence will apply. None of them are applicable here. Okay, so that was the first set of problems. For the next set, we have 6 more problems. For questions 10 through 15, we're going to actually use our pink sheets. Well, no. Yeah, we can use our pink sheets, but we're going to state the postulate that proves these triangles are congruent. And then, not only that, we're going to use our congruence statement. If the triangles are not congruent, again, like last time, we'll just write not applicable, or they're not congruent. Okay, so what do we have here? The first thing you really want to do, mark your figure if it's not already marked. We got a side, side, and we really have a third side, that's the reflexive side. Do we have that here? Single, double, triple slash, single, double, triple slash. So that seems pretty safe to say it's a side, side, side congruence. That is the reason, that's the postulate that proves they're congruent. But what is the congruence statement? You have a lot of freedom for how you're going to write the left side. I'm just going to say, sorry, that was going to be a triangle. I'll make that into a letter A. Triangle AKC. So I'm spanning the first side with a single slash, and then I'm spanning the side with a double slash. That's really important that you go in the same order. So single slash, double slash. That triangle is going to be congruent to triangle. Well, AKC is the top left. I need to go down to the lower right. So I need to do the single slash. So that's spanning CB. And then I go to the double slash. And then that's BA. CBA. AKC. Has to go in the same order. So AKC, that's spanning the single slash, double slash, CBA, single slash, double slash. And then, of course, we end up with the third slash after that. Well, that's number 10. Number 11, what do we have here? We were told that these two sides are congruent, and these two sides are congruent, single slash and double slash. We also know for sure these are vertical angles. So that is your angle. What do we have? Side, angle, side. Single slash, single arc, double slash. Side, angle, side. Single slash, single arc, double slash. So that is a very classic case of side, angle, side. And what is our congruence statement? Again, I'm going to go in an order, and I just need to make sure I go in the same order for the other one. The left side, you can really do whatever you want as long as you're going in one direction. A, B, C. Triangle ABC is congruent to triangle. Okay, so AB, I had the side with no slashes. And then next, I came across the double slash side. So if I'm going to go the same way, I need to go from P to Q. That's the no slash. And then I come across the double slash. So that's P, Q, C. Notice how they both share the letter C, which is fine. So triangle ABC is congruent to triangle PQC. That is my congruence statement. And what about number 12? Let's see what we have. Side, side. And we really know, again, there's some vertical angles here. Side, side angle, side, side angle. Is side, side angle one of them? Or you could say angle, side, side. No, neither one of those is a way we can prove congruence. So none of those 4 ways applies, which really just means these triangles cannot be proven to be congruent. Moving on to number 13. We have a right angle in both. We have an angled, a side that's got a single slash in both. And again, we have vertical angles. So that is what? We have angle, angle, side. Starting with the right angle and going to the vertical, we have angle, angle, side. Angle, angle, side. So that's exactly what we have. I'm going to just write it up here. Angle, angle, side, out of the way. What is my congruent statement? Well, you can start, again, wherever you want. I'm just going to say NMC. So where did I start? That's going to be congruent too. I started with the angle with no arc or right angle symbol. So I need to do that in the other one. Triangle B. And then M is this next letter I did. That was the right angle symbol, followed by the single arc for the vertical angle. And that's also going to be the same letter in the other one. So NMC, BAC. That is my congruent statement. Number 14. Okay, notice what we have here. We have these feathers here that indicate parallel lines. That is really the key to this problem. Parallel lines. So what does that tell us? Not only do we have parallel lines, but we also have this transversal. And that is really the key to the problem. That means we have alternate interior angles. Alternate interior angles right here that I just drew with a single arc. And what else do I have? I have a side that's shared, so that's my reflexive side. So now I have side, angle, side. This angle is included between the two sides. Side, angle, side. So that's a pretty easy one to do once you realize that you have alternate interior angles and that you have a reflexive side. If you didn't notice that, you'd probably be tempted to say you can't prove any congruence. But you must notice that they're parallel lines and there's a shared side. So what am I going to say? Angle, I'll just start with the upper right this time. Angle, triangle ABC. A was the one with the single arc. B was, let's see, how would I explain that? A was the single arc, so I'm going to say C is the single arc in the other one. B is the side off in opposite corners, but you could also say it's between the single slash and the no slash. So what's between the single and the no slash? Over here we had between the single slash and the no slash, that's a G. And then ABC. C was the one, ABC. It also had no arc, but it's between the no slash and the double slash. So in the other triangle, between the no arc and the double slash, that is A. So A, B, C, and C, G, A. You have to be pretty careful on these. If you don't take your time, you might end up missing them, which is kind of a pity because these are not hard problems otherwise. What do we have here? We have angle. It might be a little hard to see, but you have a single arc here and a single arc there. So we actually have a right angle, a single slash, and a single arc. Right angle, single slash, single arc. So that is angle, side, angle, angle, side, angle. Our congruent statement would be, I'm just going to say go with the right angle, and then go to the single arc, AC, and then the one with no angle marking at all. Triangle ACB is going to be congruent to triangle. So I started with the right angle, that is N. I went to the single arc, which is now y, and then no angle marking at all is p, NYP. So we have triangle ACB is congruent to triangle NYP.